Hello, in this tutorial we will learn how to optimize a decision tree that has been developed in RapidMiner for binary classification. In particular, we will look at the optimize parameters operator in RapidMiner that allows us to systematically explore various combinations of different parameters and from that pick the parameters that result in the best decision tree. The metric that we are using here is accuracy, and we'll once the tree has been optimized, we'll examine the accuracy of the resulting model. So very quickly, the data set that we are using is the same as the one that I used in the previous tutorial where I showed you how to build a decision tree from training data. So this is a banking application. You can see in the small slice of data over here. So the target variable is the one shaded in yellow. It's a personal loan variable. So the bank had done a campaign recently where they made an offer of a personal loan to their customer, and those customers who accepted the personal loan offer were categorized as a 1, and those who did not were categorized as 0. And for every customer, you have different features or characteristics of the customer, such as age, income, number of people in the family, the average credit card balance, whether or not they had a CD account with the bank, all those characteristics. So the idea is to be able to use these characteristics and based on questions asked about these characteristics to be able to build a decision tree that classifies customers as accurately as possible into one of these two categories. That is, either they accepted the personal loan or they didn't. And during that prior tutorial, I showed you how when building the decision tree operator that you see has various parameters that one can set. And we played around in particular with two parameters. One is the minimum leaf size, and the other is the minimum size of a node for a split. And in the process of that experimentation, I showed you that changing these two parameter values has an impact, and sometimes a significant impact, on the performance of the decision tree as measured by accuracy, and also on the characteristics of the tree itself, namely its branching characteristics, how deep the tree is, how detailed the tree is, how many leaf nodes are there. So the general structural characteristics of the tree itself. So in this tutorial, what we're going to see is a particular RapidMiner operator called optimize parameters with a grid pattern that allows us to systematically search through these different combinations of parameters and pick the decision tree that has the best performance. So with that, let me start up RapidMiner. Here is the RapidMiner interface. So the first step, of course, is to retrieve the data. So I drag and drop the bank personal loan data into the process panel, and that activates the retrieve operator. The next operator I will use is set role, and I use it to tell RapidMiner. So I connected set role with the previous operator, I chained it through, and now I highlight set role and I tell RapidMiner through the parameter panel that personal loan, that particular attribute, is the target variable. So I specify to RapidMiner that personal loan is a label, and that's how it knows that it's a target variable. So now comes the main operator that we are focusing on in this tutorial, and that is the optimize parameters. So here's the optimize parameters operator, and I'm going to pick the optimize parameter grid. So it searches the combinations in a grid. Think of the parameter combinations of values of the different parameters as a grid, and it searches from one point of the grid to another. So I drag and drop this operator in here, and I connect it to the immediately preceding operator. Now notice that this optimize parameter, the operator looks a little different from the other ones in that there seems to be a rectangle behind the rectangle, and that is to signify that this is a nested operator. And the way this works is, think of the optimize parameters operator as the main program, and behind it or nested underneath it, which is the box below, we will define a process where the decision tree will actually be determined. And what this main program does is it runs and reruns the subroutine many times for different values of different combinations of the parameters, and by doing so it picks the parameter combination that gives the best performance in terms of the decision tree. So at this point I got to pause on the optimize parameter operator itself. I'll come back to it, but I double click on that operator and that drops me down one level to build the subroutine, as it were. So the first operator that I will use is split data, and I put it into the process box here, and I connect it to the input port. So this raw data is coming in through the input port from the higher level. So the higher level transmits this data down to the lower level here, and I am now going to split this data into a training and a validation data set. I do that by going to the parameter panel, clicking on edit enumeration, and then add entry. 70% of the records go through the first partition, add entry again, 0.3, 30% go to the second partition. The first partition will be used for validation, the second partition for training, 70-30 split of the records. So I'm done with the split data, and now I can bring in the decision tree operator itself. So here is the decision tree operator. I pick that up from the operator panel, drop it into the process box, and I connect it to the split data operator so that the first partition, the training partition, can feed into the decision tree. So I have supplied the training data to the decision tree, and the train model will be transmitted out from this operator through this model output port. Okay, so now I can take this and do some prediction. This train model, I can take this and use it for some predictions. So I will do that using the apply model operator. So I take apply model and drop it in here. And apply model needs two inputs. One is the trained model itself. So here is the trained model, and I give it the validation data from the second partition of split data. So I connected the validation operator. So what the apply model does is it takes the trained decision tree, so the decision rules, and applies it to the validation data. So it predicts for each of those customers in the second partition, it predicts which class they belong to. Did they or did they not accept the loan? And then we can compare the predicted class with the actual class, and that will give us our performance metrics as to how good the decision tree is. So now I'm in a position to actually measure performance. So I use that performance operator. And since there are a whole bunch of them, I need to be careful that I pick the correct one. Since in this context, we are looking at a binary classification problem, I pick up the performance binomial classification operator. I put it in here. And the input to the performance measurement operator is the actual and predicted classes. So that I do by connecting the label output from the apply model operator to the input of performance. And when I click on the performance operator, you can see on the parameter panel we have identified accuracy as the performance metric that we are using to judge the performance of this decision tree. There are other metrics, as you know, if you scroll down, and you can use other metrics as well, but we have picked accuracy. So we have done the setting up of the decision tree, training it, and then evaluating its performance. Of course, this information has to be fed back to the upper level so that it can try different combinations of parameters. So now I take the performance output from the performance operator and I connect it to performance here. This will be fed back to the upper level. Okay, I need to connect the output, the model rather, to the output port also. So here I have set up the subroutine, as it were. What all this subroutine does is it splits the data into two pieces, into two subsets, a training and a validation subset. The training subset is fed to the decision tree operator, which mines that subset and derives a decision tree from it. That decision tree is applied to the validation data set, and the performance is measured. So the input raw data comes in from the upper level. You compute your decision tree, develop your decision tree, check its performance, and feed the performance and the model back to the higher level. So now let's go back to the upper level, and now I'm in a position to continue building this optimized parameter. So let me click on that, and here we will edit the parameter settings. So all the options that you want to pick to be explored, you do that by clicking on edit parameter settings. Now let's look at this dialog box. So all these operators that you see on the left hand side, these are the operators that show up in the subroutine or in the lower level. So you may recall I had split data, I had the decision tree operator, I had apply model, and then I had performance. So out of these four operators, I want to explore different options of parameters for just the decision tree operator. Okay, so as soon as I click on decision tree, you can see it lists all the parameters of that particular operator, and I could in principle try out different combinations of values for all the different parameters, but I'll pick just a few so you can get the idea of what this grid exploration looks like. Okay, so one of the parameters that we can choose different options for is the criterion. So this is the branching criterion, and you can see over here, as soon as I select this criterion, it gives me all the different options for this criterion value. So these are different measures of impurity, like the Gini index and so forth. So I will pick some of these to be tried out. So I remove least square, I remove accuracy, I remove gain ratio. So just to keep things simple, I've just told RapidMiner that when it comes to this criterion parameter, just try out these two values only. Only try out these two values for criterion. In other words, use entropy or use Gini as the impurity metric in your criterion for splitting the nodes. So you can see automatically RapidMiner has determined that there are two combinations, so there are two alternatives that it has to try. Now let's go on to another parameter that's important in the case of decision trees, and that is the maximal depth. So this is important because if you make the tree very deep, then it will try to fit the training data, of course, but there is a danger that it might overfit the training data, and then when you give it actual validation data, it may not do particularly well. So the maximum depth is a parameter for which I may want to try out different values. So you can see RapidMiner has specified some default minimum and maximum range for this maximal depth. I'm going to change that. I'm going to just change that to 1 to, let's say, 20, and I want 5 steps. Okay, so as soon as we do that, you can see that RapidMiner has identified 1, 5, 9, 12, 16, and 20 as the options. So there are 6 choices over here, and there were 2 choices for the criterion. That makes for a total of 12 combinations, 6 times 2 combinations that RapidMiner has to try out for the grid search. Now, out of the remaining parameters, I'm also going to choose minimum leaf size, because you may remember from my previous tutorial that minimum leaf size had a fairly significant impact on both the performance as well as the structural characteristics of the tree. So I select it for as a parameter for which I want to try different values, and I'm going to change these defaults here. The minimum can stay 1, but the maximum, I will change that to, let's say, 20, and I'll do that in steps of 5. Okay, so again, here you have 1, 2, 3, 4, 5, 6. 6 options. So once you look at all the different options that are available for each of these 3 parameters, we get a total of 72 combinations that have to be tried. Okay, so we've set up the grid pattern that needs to be searched, as it were. So the options have been set up. So now all I have to do is connect the various outputs to results, and so that I can see them. I certainly want to see the performance metric that results. I want to see the tree itself. I want to see the model, and I want to see the optimized parameters of the model that are determined. So I want to see all 3 outputs, and now everything has been set up to try out my optimization. So let's run this process. So you can see that the optimization process has run its course, and let's look at the various outputs. So these are the parameters that have been designed. Remember, the grid search, what it does, the optimize parameter operator, what it does, it tries different alternatives for each parameter. So you have different sets of different combinations of values that it tries, and what it has found is that these 3 values, that is, the criterion equals information gain, maximum depth equals 16, and minimum leaf size equals 20, is what gave us the best performance in terms of accuracy. And that performance you can see here in this summary. You can see the confusion matrix over here. So both the overall accuracy is very high. It's 99%. Okay, so let's look at the performance vector itself by clicking on performance vector over here. So you can see the confusion matrix, and this gives us a clearer picture of how the optimized tree has performed. So you can see the overall accuracy is 99%. That's really very good. But what is even better is if we look at each category. So category 0 are the customers who did not accept the loan, okay, the personal loan offer. There, the accuracy is 99.71. And for those customers who actually accepted the loan offer, that is category 1, the accuracy is also very high, is 92.36. You may remember that for the unoptimized model, when we built the decision tree model in the previous tutorial, the accuracy for this category 1 was around 70%, if I remember correctly, 72%. So the optimization process has resulted in a remarkable increase in the accuracy of the model. Okay, so we have seen what the optimal parameters are, and let's look at the tree itself. So here's the decision tree, and look at it. It has a very nice, neat structure. It is not terribly deep. It doesn't have too many branches. So in terms of its structural characteristics, is relatively easy to comprehend. You don't have extremely deep paths or anything like that. So this is a structure that's easy to comprehend. Now, if you look at the various leaf nodes, when you see a node here which is completely red or almost completely red, this is a very pure node. So it's almost all red. Maybe it's completely one category. Yes, it is. So if I put my cursor on that leaf node, you can see that there are 0 customers of category 0 and 221 customers of category 1. Similarly, here I see a thin red partition over here. So there are 504 customers of category 0 and only 6 customers of category 1. So it's very pure. This not completely pure, but very pure. Similarly, if I look at this leaf node, it's also very pure. There are 2,524 customers of category 0 and only 17 customers of category 1. It's a very pure node also. However, some of these other leaf nodes, for example, this particular one is partly blue and partly red, so we couldn't classify them absolutely cleanly. You can see that there are 106 customers of category 0 and 16 customers of category 1. So this is the optimized decision tree. And if you remember some of the trees that we came up with in the first tutorial, their structure was really quite nasty, in the sense that there were a lot of branches, a lot of high levels of depth, again making it hard to comprehend also. So the net result of optimization over here, you can see both in terms of accuracy. Here's the performance vector, the accuracy, both overall accuracy as well as for each class individually, are very high. And the tree itself structurally has some very nice properties in terms of being able to comprehend how the tree functions. So coming back to the design, here is the process that we had designed for optimization. So in this tutorial, I showed you how to set up the optimize parameters operator to be able to systematically explore different combinations of values for the parameters for the decision tree operator. Thank you for your attention. Thank you for watching.